Okay, all right, number 6, last one. All right, so before we start this one, this is going to be another way we can use the BCA table, okay? I want you to watch this video as a refresher about molarity, okay? It's kind of a cool little video. I hope it comes through. I found it on Twitter, okay? But basically, remember, molarity is a ratio of moles per 1 liter, okay? Right? So this is the new conversion factor we're going to use in this problem in order to use the BCA table, okay? All right, so 10 milliliters of a 0.5 molar Na2S solution, okay, is reacted with excess CuSO4. What mass of CuS is produced, okay? All right, so we're going to be given now 10 milliliters of this Na2S solution, all right? But again, we need to put it into moles, all right? So first we need to put it into liters, milliliters, 1 liter, okay? And then we're going to use the molarity, all right? So if it's 0.5 molar, that means 0.5 moles in 1 liter, okay? So that's going to cancel. Oops, not the 1,000. That's going to cancel, okay? All right, so when I find the moles for this BCA table, I'm going to do 10 divided by 1,000, okay, 0.01 liters. You could have just put that if you want first. And then it's going to be times 0.5. So it's going to be 0.005 moles of Na2S. Okay, so this is a way that you can use molarity. If you're given the milliliters or the volume of a solution, you can use that also to find the moles to stick it into the BCA table. Okay, all right, so let's go ahead and balance this. So since I see a polyatomic here, I'm going to try to keep that together. So I have 1 SO4 on both sides, 2 NAs, 2 NAs, 1 S, 1 S, 1 copper, 1 copper. So how will you look at that? 1, 1, 1, 1. Couldn't be any easier. All right. Okay, so my given is going to be 0.005 moles of Na2S, okay? And excess this, so who cares? And the products are going to start with nothing. All right, I'm going to take away 0.005 moles of the Na2S to leave me with nothing. And then remember, that's going to become my basis for everything else. Okay, my given goes on the bottom, which is 1. That's because of this. Okay, and then I'll pull down all these other coefficients. But this one, as we already said, is a 1 to 1 to 1 to 1. So everybody is just going to be 0.005. Okay, and the CuSO4 we're just going to call excess because we don't care. All right, what kind of reaction is this? This looks like a double replacement because everyone is switching partners. Okay, and my word equation, 0.005 moles of aqueous, look at that, I remembered this time, sodium sulfide, right, watch the ending, reacts with excess copper sulfate. Okay, that's a polyatomic. All right, so remember, sulfate is a -2, and there's only 1 copper, so that has to be a +2. Okay, so that's going to be copper 2 sulfate. All right, to form, oh, I guess I should have said aqueous. See, I was so proud of myself for remembering. Okay, to form 0.005 moles of aqueous sodium sulfate and 0.005 moles of aqueous copper 2 sulfide. Okay, make sure you get the Roman numeral. All right, final answer in grams or moles. Let's see what I'm looking for. Okay, I was looking for the mass of copper sulfide, so I need to go ahead and convert that again. So 0.005 moles of copper sulfate. Okay, 1 mole of CuS, that should be easy enough. Let me find my periodic table. Okay, so copper for the molar mass, oh my God, this is so tiny I can't see it, is, someday this is going to load. There it goes, okay. So let's see, copper is 63.55 plus sulfur is 32.06. All right, gives me a molar mass of 95.61 grams of CuS. Okay, so times 0.005 is going to be a mass of 0.48 grams of copper 2 sulfide. 48 grams copper 2 sulfide. Okay, all right, and there it is. Day 34, done.